Hello, good morning, everyone. Welcome to this new webinar of OutBack Power. My name is Miguel Ángel Alquicira, and I'm an applications and sales engineer for OutBack Power Mexico. I've been working for OutBack for 1 year and a half, but I have a lot of experience in solar and energy storage market. So the idea of this webinar is to show you the smallest system of OutBack Power. So um, the idea is to understand which are the components and how do they work together in order to have a complete solution of an OutBack hybrid system. It is very important to understand this small system in order to understand bigger systems. So let's start it. First of all, what we need to know is that for a hybrid system, everything you need, we have it in one brand solution. It is important to know that we have, since the point of generation, I mean, it could be, for example, a PV model, it could be a generator or the grid or a micro hydro plant, or it doesn't matter the source um, that you want to use for generate your power. We have everything in between. We have the inverter charger, we have the charge controller, the load center, the balance of systems. We have the batteries, enclosures, cables, everything we have in one brand solution. So it is easier for you to choose all these components because we know how do they work together. So this is one of our biggest strengths as a brand. So before starting to talk about the FLEXpower one, we want to talk about how to build BOM, the build of materials. It could be complicated to have all the experience to know how many components and which of them are we going to use for a complete system. For example, let's see these images. If you have to choose all the components of the separate components, maybe you will need to think in an inverter, charge controller, batteries, enclosures, the cables from the batteries, the way that we're going to interconnect those batteries, the breaker for protection. We will need load centers, accessories, we need cables, terminals, screws, nuts, breakers, the FlexNet DC, the Mate 3S, blah, 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 blah. We will need a lot of components. So, what will happen if you don't know all the name of those parts? If you forget something, if you do not know how they work together, you don't know how to install it, how to communicate them, how to choose the correct components for this kind of system. So uh, if you choose to ask for a BOM with separate components, maybe you could have something like this. If you know OutBack Power products, well, it cannot be a big deal. But if you do not, and if you are entering to know how or which components are going to work together, you would need maybe a list like this. You need the inverter, the charge controller, the Mate3S, the hub, the FlexNet, and all these components. So it could be complex. So if this is the list for a FLEXpower 1, imagine if you need a FLEXpower 4 or a FLEXpower Radiant, or if you need something with a different kind of systems. If you need, for example, a system with 8 inverters, so you would need a lot of components. So it can be complicated to choose the correct ones, to make that fix together, and to ask for everything. But now let's think, what if I miss something? Those kind of systems are installed in most of the cases in remote locations. So imagine you are at the middle of the desert, or you are in a mountain, or you are not exactly in a remote location, but where you cannot have all the things that you would need if you don't bring it with yourself. So what happens if you forget a cable, a screw, or a nut, or a component, uh, or you don't have enough materials to install your system? So it can be really, really complicated to get the things that you need. So in order to avoid these kind of things, there is a BOM with integrated systems. Our integrated systems have everything that you need, and they are not only the devices, but the accessories that you will need. They are already pre-bundled and pre-tested in order that you do not have problems with the installation. A FLEXpower one, the components are uh, inverter charger. It has two FLEXware 250. Those FLEXware have inside the DC one has GFDI breaker. It has a PV array breaker, the battery breaker, a chart controller. It has this kind of conduit. The AC FLEXware have the inverter for input, output, and bypass. We have a FlexNet DC, a Hub 10, Matrix S, and a FlexMax FM80. So if everything is inside and is integrated and is pre-bundled, you don't have to think in all the separate components that you would need. So you just need to install, as we will see in a few minutes, and then you will have to worry about the commissioning. So the bomb will see like this. You will need an FP1, that it's a pre-wired solution with the single inverter, AC and DC boxes, 120 VAC bypass, the GFCI, the breaker for the batteries, the GFDI, the breaker for the PV array, the Mate3S, the Hub 10, the remote temperature sensor, the FlexMax 80, and a FlexNet DC with surge protector. So it is easier, really easier for you to acquire these kind of systems. So your BOM is reduced to the FLEXpower, the combiner box, I'm sorry, the breakers for the PV array, two cables for the batteries, and the batteries and the enclosure. And if you buy batteries like our RE high capacity solution, you will have the battery integrated. So this BOM is easier to ask than the other one with separate components. So now that we have understood that it is easier to order an FP1 than separate components, and that we do know that using an FP1 make us um, easier the design of a system, let's talk about the installation. If we talk about installation of an FLEXpower one, uh, we won't talk about how do the components work together because the components already work together pre-bonded by the factory. So you don't need them to know how are you going to wire the chart controller with inverter or the inverter with the flex or AC and DC or how the wiring of the flex net. No, you don't need it because all of these are pre-wired in the fixture. So the first part of insulation is the mounting. Every FLEXpower one has a mounting wall bracket that you can put it in the wall in a plywood, for example, or in almost any surface that you would need. Everything you need to put is to put that bracket to fix it to the wall with screws, and that's it. There's three cases that are shown in your screen. One could be in a wall, in a plywood, or if you have separate wall studs. Once you have installed the mounting wall bracket, it is easier just to lift the mounting plate above the wall bracket. So if you just have to slide the, the mounting plate, and then you have to secure the mounting plate to the wall with the screws that need to be put in the inferior part. Those three, and that's it. You don't need to present first the inverter and then to use different kind of screws or anything. You just need to lift the mounting plate and secure mounting plate, and that's it. It's very easy. Of course, we will need clearances. That's the minimum recommended clearance above and on sides. This is for that you could manipulate tools in order to lift the clearance enough for cooling, for security, and well, in order that the installation can be practical. So we have 12 inches for above and 12 inches on sides. And we would recommend 36 inches for the clearance in front. Now, let's talk about the wiring. The overview of this wiring can be seen like this. In the central part, you will see the FLEXpower one. At the center, you will see the inverter charger. Then above, you will see the AC FLEXware. The DC FLEXware is at the bottom. This is the FlexNet DC, the Hub 10.3, and the May 3S. And in this part, you will see the FM80. So if you do recognize these components, we'll see. First of all, the PV connections. If you have a PV array, you just need to install a combiner box, that it could be our PV8, for example, or it could be the PV6, or even if you need a rapid shutdown, it could be our ICS Plus. So everything you need is to bring this positive wiring into the breakers. one breaker for each string, and at the top, all the strings will be joining, and you will only um, will have one positive cable from the combiner box to the PV circuit breaker. In the case of the negative, we have a bus bar where you will join all the negative cables from the strings. And for the output, you will have only one negative that it's going to pass through the DC FLEXware, and you will connect it in the terminal that it says PV negative in the chart controller. For the case of the grounding, it's very similar. The ground, everything, every OutBack device has its own terminal log for grounding, so it will be very easy to identify it. The next part is the installations of the batteries with the shunt. Here we have two different um, type of cable connections. The first one is when you have the FlexNet DC. You will need to put the bolt, a log washer, a flat washer, then the chart controller battery lock, and the inverter battery lock. Everything it will be put on the shunt. If you do not have the FlexNet DC, you will have to put it in the terminal front of the inverter. That's the difference. This is the shunt. The shunt it is joined to the terminal of the inverter by this device, and well, you will need only to put the positive of the battery bank to the inverter in the breaker of 175 amps for the 48 models, and 250 amps for 24 volt models. The negative will come to the shunt in the case of the FlexNet DC using, and if not, direct to the inverter terminal front. And the remote temperature sensor will have its own terminal here in the inverter. Then we will talk about the wiring of the AC output. The FlexWare, the AC FlexWare, it is at the top of the FLEXpower. So at the top we will see a bus bar of neutral. This neutral will come to the bus bar of neutral of your load center, and you will have the breaker of the AC output with the line 1 or the hot to the panel or sub panel terminal in order to power your devices. For the case of ground, it is exactly the same. We will have a grounding bus bar that will be connected to the grounding bus bar of your panel, and that's it. For the AC input, if you have an AC generator or you're going to use the utility grid for the AC input, everything you will need is to identify the input breaker, that it will be at the top of the FlexWare, and to connect from the main panel to the input breaker. The neutral comes from one bus bar of another one. That's exactly the same. And same case for the ground. And that's it. So maybe you could think that if you will have the grid as a AC source, how uh, can be avoided that you have a short circuit because you are injecting uh, energy with the AC output, and you are using the energy of the grid for the AC input. So what would happen? That's why every FLEXpower one has a bypass. The bypass switch avoids that the input and the output works at the same time, as we'll see in this diagram. If the AC source is working, let's think that you have to feed your loads directly by the grid because you're going to make a maintenance to the batteries, for example. Then what you need to do is to open the 60 amp breaker for the input, and then the energy will flow from the AC source directly to the loads. If this breaker, the 60 amp bypass breaker, is closed, then this breaker, the 60 amp breaker for the output, will be open. So the energy will flow like this, directly to the AC loads. What happens if I want to use the AC output? Then this breaker for the 60 amp output breaker is closed. Then the 60 amp bypass breaker will be open. So those cannot be open at the same time or closed at the same time. That's how the bypass switch works. Great, don't you think? So the wiring of ground. As I said before, every OutBack power device has its own terminal lock or bus bar for grounding. So everything is identified by the symbol of grounding, this one. So everything you need to do is to connect all the devices at the same port and then to the primary ground system. It is really, really easy. Okay, now you have installed your FLEXpower 1, you have completed the wiring, and you have all your devices connected and ready to work. So let's talk now about the commissioning. Now, it is important to say that this information it is not intended to replace national or local safety standard. So first of all, what you need to know is what your local safety regulation said. So this is only for information and knowing the steps that you need to follow in order to have a successful installation. But I repeat, you need to know perfectly your local regulation. In every country has its own, so it doesn't matter which. You need to know it, and you need to apply it when you are doing your installation. So, saying this, let's start. First of all, you will need to double check all wiring connections. It can be done only by looking, or you could check with your multimeter. You could check the different part of the wiring that have continuity. in order to be sure that you have well done your connections and that your cables and devices are working well. Then inspect enclosure to be sure that, inspect enclosure to be sure that no tools or device were left inside. Sorry for this word, is device. Um, because believe me, it happens. It really happened. I have checked installations where um, I have found tools. I have found even hammers and any kind of tools inside, and they can represent a problem in the future. So be careful with that. You will have to verify that all breakers are in the off position, I mean open. You will have to connect the power sources last. And of course, you will need all the personal protective equipment to safely commission system. And at the beginning, please disconnect all the AC loads. So let's start with the steps. First, for the commissioning, you will need to test the battery terminal for correct voltage and polarity. So using a multimeter, you could check in the shunt and in the input of the breaker in order to check this voltage and polarity. You will check your 12, 24, or 48 volts. It depends on which system are you working with. And what you need to know is that the DC cable from the battery connects to the terminal to the circuit breaker that is opposite to the inverter DC cable. Two, turn on, close the GFDI and the FlexNet DC circuit breakers that are clearly labeled in the DC FLEXware. When you close the GFDI breaker, the FlexMax charge controller will power up. Why the GFDI at the beginning? Well, if there is a ground fault in any of your devices or any part of the installation, this breaker will open. So if you do not close this breaker first, if you have that fault, it can be damaged to your system. So the idea to close this breaker first is exactly to protect your devices from a ground fault. As the FlexMax 80 will power up, you will need to follow the instructions for the selection of voltage and language. With the GFDI, the Mate 3S will power up too. So you will see the Mate starting. 3. You have to verify the PV array voltage and polarity too. You will do this checking with your multimeter from the PV array breaker input and the PV negative terminal in the FlexMax. Then turn on the PV array circuit breaker. When you turn on that breaker, you will see in the FlexMax chart controller the voltage in current that you are in that moment generating. You can check it in this screen. You will see voltage, you will see current, you will see instant power, and it will start to count the energy, I mean kilowatt hours. Then you have to turn on the DC circuit breaker from the batteries to the inverter. It's the big one. You will recognize it easily because not only is the big one, but it has a red cover around it. So as I said before, this breaker is 175 amps for the 48 models and 250 for the 24-volt models. When you turn on this breaker, your inverter will power up. So when you power up the inverter, you will start to hear the noise of the fan. When it starts, it will do, and that's when you see that your inverter is working. And you will see that it will start to light the LED indicators. Then check that you have 120 volts in the AC output circuit breakers. That you will check it in the terminals that are connected to the inverter. So it will be from the AC output breaker and the bus bar of neutral. If you do not have 120 volts here, be sure that your inverter is on. So by factory, it could be on, but if not, you will check the um, the the jumper inside the inverter in order to check that it is on. Then you have to turn on the AC output circuit breaker and the AC outlet circuit breaker. In every FLEXpower one, you have an AC outlet right here and have its own circuit breaker. So when you turn on, you could check it, the voltage and polarity in the outlet. Then you have to verify that you have 120 on the input circuit breakers. If you have a generator running or you are using the grid in this breaker, you will have to check that you have that voltage. Then if you are going to use your input, you just need to turn on the AC input breaker and then you have it. Once you have everything turned on, you will have to check that your installation is working fine by turning on AC output loads. So in your stop panel, check your circuits or check your devices in order to be sure that you have everything working fine. Then, in order to be sure, you have to verify LED indicators and meters. So, where do you have it? In the inverter, you will have the battery status and the inverter status. You have more LEDs on the May 3S. You have more LEDs in your FlexNet DC that you will see here the battery status in the battery state of charge. And the displays. You will have one display in your FM80 and one display in your May 3S. Now, You have installed successfully your FLEXpower 1 system. Then you have been working with your loads with your system, so you're really happy with your functionality. But for one reason, you need to energize the system. For example, for a maintenance. For example, that you will need to replace one component, or because you need to well, whatever you need to do, you need to de-energize the system. So the way to make the decommissioning is exactly the opposite that we have done for decommissioning. So first of all, you need to turn off the AC circuit breakers. I mean, in order to open and that you do not have power the loads or the AC input. Then you have to turn off the DC circuit breaker for the battery, I mean the big one. Then turn off the PV circuit breaker. It's here. And turn off the GFDI circuit breaker. If you see, when we make the commissioning, we will turn on the GFDI first. Well, for the decommissioning, we have to turn off the GFDI circuit breaker at the end. Why? For the same reason. If you have a fault in your system and you do not have open the GFDI circuit breaker, that damage can be conducted to your device. So this is one of the most important devices talking about protection, the GFDI circuit breaker. In many of cases, people it is not usual that people that buy separate components use it because of the fact that they want to save as much money as they can. So, well, it is not exactly necessary for the operation of the equipment, but it is really, really necessary for the protection of the equipment. So, if you are planning to save money for a breaker, I think that it would be better to spend for this breaker instead of spend money for reparation of your bigger devices like your inverter or your charge controller or whatever. And finally, once that we have quit all the power from our system, we will need to verify that we have 0 volts in battery terminals, in the terminals of the PV array, and the terminals of the AC output circuit breakers. So when I check it, that I have 0 volts, now I can manipulate my system with confidence. Now, as a summary, first, we need to verify sources with circuit breakers off. I mean that there is no power anywhere. Check battery voltage and polarity, then check PV voltage and polarity, and then check AC input voltages in all sources. I mean in hotline and neutral. If I have the grid, if I have the generator or whatever. Then for turning on the circuit breakers, we will have first of all, remember the GFDI. So we will have to turn on the battery, the AC output, input, or PV. The correct way to do it is first GFDI, then PV array, then battery to inverter, and then AC breakers. And then you have to check all the AC output voltages and verify that you have the correct readings in your meter and in the screens and with the LED indicators. So you will see it is really easy to install one's FLEXpower 1, to commission a FLEXpower 1 and to use it. Then what would you choose to do with this? Whatever you want. So there are more webinars about the operation modes that are the way that you will use your FLEXpower as you wish. So uh, it is very important that we understand the practicality and the easy way to order, to install, and to commission, to do the commissioning for a FLEXpower 1 as the smallest complete FLEXpower OutBack power system. So with this understanding, it will be easy to replicate this procedure to almost every OutBack power system. So let's see if you have any questions. We could talk about this. Okay, yes, I see there are questions. Okay, let's see. Robert Monk says, I definitely want to walk through the DC bus battery voltage calibration procedures. Yes. Somebody's asking, have you developed unified system operating manual and installer manuals for these integrated systems? Sourcing printed are online documents for the individual components. Well, yes. In our web page, all these diagrams that you have seen in the presentation are included in the quick start guides. It is very important that you have in there at the moment of your installation the quick start guides for the FLEXpower. It doesn't matter if it is FLEXpower 1, FLEXpower 2, FLEXpower 3, or even FLEXpower 4 or FLEXpower Radiant. It is they have all these diagrams of wiring and the procedure of commissioning, that it will be easy for you to do it instead of reading all the manual. The manual has, if I'm not wrong, like 80 or 90 pages, that it could be difficult to see what it helps to you at the moment of your installation. So yes, everything is unified in the quick start guides. You can check it on our website. Dennis Aaron asking if I'll be sharing the slide deck and training recording. Yes, of course. This training it's being recording and it will be on the web page in the section of webinars very soon. My recommendation for wiring protection devices in the case of multiple FLEXpower, for example, as a three-phase system using the FLEXpower 3, ask Robert Monk. Well, the only FLEXpower system has its own GFDI. We have a GFDI with dual pole or with 4 poles. So if you use a FLEXpower 3, there is a GFDI with 4 poles for that system. So you don't need to use three GFDI for of single pole. So, but don't worry, it is included in the FLEXpower 3. Norberto Perez is asking, yes, as I said before, yes, this presentation will be recorded and will be in the web page. A webinar, Christopher Warfel is asking for a webinar about the current NEC. Uh, yeah, for rapid shutdown, it will be check it on our calendar. It is already scheduled. So yes, it will be very, very soon. I'm not sure the date, but if you check the schedule of the webinars that are now in the web page, one is for rapid shutdown for neck. So, Christopher, I'm sorry that you were disappointed by with this webinar, but this information it is not for this one, but we will have one soon. Please check it on our webpage. Then Eduardo Delgado is asking if there are any steps of integration required when adding a power generator. Well, yes. First of all, you will need to connect the generator in the PV input, and then it depends on how you wanted to use the generator for your system. For example, if you need to use your generator automatically, you will need to program with the AGS, Advanced Generator Start. So it is a different algorithm that you could program from the May 3S. So if you need more information about AGS, please send me an email, and of course I could help you with the programming. Then the dimension when shipping a 320 NC system. Well, the dimension of the FLEXpower are on the spec sheet on the web page. Not sure, I do not have it in mind, but they are on the spec sheet. You could check it right there. So when in the case of a 320 NC system, I mean that's system edge. In the system edge part in the spec sheet, it will be the packaging dimensions too. I'm sorry that I cannot answer right now, but you need to check it on the web page. Then FLEXnet DC is set to 100% when it is turned on. Should this be done? Ask Bruce Fiero. Should this be done when battery is charging or at rest? Well, for the configuration of your FLEXnet DC, you will need to do a different method. So there is exactly a method for FLEXnet DC. You could check it on the web page too in the part of a quick start guide. There's a quick start guide for the FLEXnet DC in order to program your system. But basically it is you have to put your capacity in amp hours of your battery bank, your charge voltage, you need to specify it, and then disconnect and connect again your FLEXnet DC. It is very, very simple. But yes, there is a quick start guide on the webpage, and even it is a video about how to do it in our YouTube channel and in What School channel too. If you have doubts, please send me an email and I will send it to you the link. Miguel Angel is asking if it includes the AFCI protection. Well, the arc fault are, well, all our devices are tested with the arc fault. So yes, it includes that protection in all of our devices. Oscar Morales is asking if I have some information about ripple effect on batteries. Well, yes, please send me an email. There is my email here in the page in order that we can share information about this. And I think that's it. I think yes, all the questions. Well, if I miss something or if you need more information about the things that we've been talking, please, here is my contact information. There is my email and my phone numbers. As I said, I'm in based on Mexico City, but there is no problem. You can call me or you can send me an email anytime you need. So thank you very much for your participation. And oh, well, I think there are more questions right now. I'm sorry. You can just Enrique Rosales is asking if you can install other type of surge protection on the FlexMax 80 different to that include okay, yes, you can we have different surge protection as OutBack devices. In the FLEXpower one, there is one that is already installed and pre-wired, but if you need for any reason to use an external device for surge protection, yes, you could do it. Then Jeremy Ashley is asking, we get to EU for NAPSET for this, correct? Well, the credits for NAPSET are if you take our courses in the US. So if you take that course, yes, you will have your credits for NAPSET. But this is only a webinar, so this information unfortunately won't give you credit for NAPSET. But you could check it in our webpage, our calendar of the courses that we are giving in Arlington, in our factory in Arlington, Washington, and in Phoenix. So I think there is all the questions right now. Thank you very much. I'm really happy to talk in this webinar. The next week, exactly the next week on 23rd, we'll have this webinar in Spanish. So if you are interested, we'll talk in 1 week. So I repeat, my name is Miguel Angel Alquicira, as you see in your screen, and thank you very much. So anything you need, please, this is my contact information. Thank you very much, and goodbye.